Hi everyone! In this video, I am exploring how Minecraft education is more than just a game, but it's an instructional tool that can support meaningful learning through engagement, problem solving, and interactive design. In these three lesson reviews, I'll be looking at how Minecraft can be used to teach different mathematical concepts, including units of measurement, multi-digit multiplication, and long division, while also evaluating its technological and pedagogical affordances. As an educator, I was especially interested in how game-based learning can promote collaboration, persistence, and deeper understanding when instruction is intentionally designed. Hi everyone, my name is Kwajane Sanders, and in this video, I'll be reviewing the Minecraft education lesson, Units of Measurement. This lesson is designed for upper elementary students and focuses on helping them understand measurement concepts, specifically working with units and applying them in different contexts. As I walk through the lesson, I'll be highlighting the game features, evaluating the technological and pedagogical affordances, and also sharing how I could see this realistically being used in my own classroom. As you can see, students are placed in this interactive Minecraft world where they are completing measurement-based tasks. One of the first things I notice is how the lesson uses NPCs and prompts to guide students through each part of the activity. I actually really like this feature because it allows students to work at their own pace while still having some structure. It reminds me of how we scaffold instruction in the classroom, but here it's embedded directly into the game, which I think is pretty cool. Another thing that stands out to me is that students are not just solving problems on paper, they are actually building and interacting with the environment. They're using blocks, distance, and space to represent measurement concepts, which makes something that can feel really abstract a lot more concrete for students. From my own experience teaching math, I've seen how difficult it can be for students to truly understand measurement when it's only presented symbolically. So seeing it represented visually like this feels really impactful. What I also like and notice about this game is that students are essentially modeling their thinking as they build. They're not just arriving at an answer, they're showing how they got there. And I think that's something that's often missing in traditional instruction. A lot of the time, students focus on getting the correct answer rather than understanding the process. But this kind of environment really slows them down in a productive way. When I think about evaluating this lesson, I'm really looking at engagement, conceptual understanding, and opportunities for collaboration, along with the technological and pedagogical affordances of the game. From a technological affordance perspective, Minecraft provides this 3D interactive environment where students can manipulate objects, build models, and explore space. That alone changes the learning experience because students are actively involved rather than passively receiving information. It also allows for a level of flexibility that you don't always get with traditional tools. Students can try something, adjust it, rebuild it, and keep going without feeling like they failed, which connects a lot to the idea of productive struggle. And from what I've seen with my own students, they're much more willing to keep trying in a game than they are on a worksheet. From a pedagogical affordance perspective, this lesson really aligns with constructivist learning. Students are building knowledge through experience, interaction, and even trial and error. They're making sense of the content as they go rather than just being told how to do it. It also supports problem solving because students have to interpret each task and figure out how to apply measurement concepts in different ways. I also see a lot of potential for collaboration here. Even if students are working individually, there's a natural opportunity for them to talk with each other, compare strategies, and help explain their thinking. And from my experience, those conversations are where a lot of learning actually happens. Another thing I keep thinking about as I'm looking at this lesson is how engaging it is without feeling like it's trying too hard to be engaging. It feels natural. Students are playing, building, exploring, but at the same time, they are learning and applying academic content. And I think that balance is really important, especially with students today who are so used to interactive environments outside of school. Thinking about how I would use this in my own classroom, I would definitely use this as a reinforcement or extension activity after introducing measurement concepts. I don't think I would use it as the very first introduction, but more as a way to deepen understanding. I could see this working really well in like a rotation model where one group is working in Minecraft while others are doing hands-on or paper-based activities. I would also want students to reflect on their thinking after completing the tasks, maybe having them explain how they built their model or how they solved a specific problem, because I think that's what really helps solidify the learning. I could also see students working in pairs and supporting each other, especially for students who may not be as familiar with the game. And overall, I think Minecraft education is a really powerful tool when it's used intentionally. It takes something like measurement, which can feel abstract or even boring to some students, and it turns it into something interactive and meaningful. At the same time, I do think it requires some planning and structure from the teacher to make sure students actually stay focused on the learning objectives. If anything, this lesson reinforced for me that students learn best when they're actively involved, when they can explore, and when they're given space to figure things out, even if that means struggling a little along the way. In general, I would say this lesson works best when it's paired with guided instruction, opportunities for reflection, and collaboration. When those pieces are in place, the game becomes more than just engaging, it becomes a tool for deeper understanding and real learning. My name is Kwajane Sanders. Thank you for watching my Minecraft video review, Lesson 1.
Hi everyone, my name is Kwajane Sanders. Welcome to my Minecraft video review number 2. For this video review, I'll be exploring the Minecraft education lesson on multi-digit multiplication and how it can be used as a tool to support student learning in a meaningful and engaging way. So to start, this lesson really focuses on helping students multiply larger numbers using place value strategies rather than just memorizing steps or algorithms. What I really like about this is that students are not just solving problems on paper, they're actually building and visualizing multiplication within the game environment, which is similar to them using manipulatives in the classroom. In Minecraft, students interact with blocks and structures that represent multiplication concepts, which helps make something that can feel very abstract much more concrete and understandable. As students move through the lesson, they're solving problems, exploring their environment, and applying multiplication in ways that feel more like problem solving than traditional math work. For example, they might be building arrays or structures that represent multiplication problems, which allows them to physically see how numbers are grouped and how place value works. This is something I immediately connected to my own classroom because I've seen how difficult it can be for students to really grasp multi-digit multiplication when it's only taught through procedures. This lesson really shifts that toward conceptual understanding. Now, in terms of game features, Minecraft education provides a really interactive and immersive environment. Students are able to move through the world, interact with objects, and receive directions or challenges through NPCs. There's also a strong element of exploration, which naturally increases engagement. Another key feature is the ability for students to collaborate or work alongside each other, which supports communication and shared problem solving. The game also provides immediate feedback, meaning students can quickly see whether their strategy worked or if they need to adjust, which is something that's not always present in traditional worksheets. When evaluating the pedagogical potential of this lesson, I'm specifically looking at both technological and pedagogical affordances. From a technological standpoint, Minecraft allows students to visualize math concepts in a way that wouldn't be possible with just paper and pencil. Students are able to manipulate and build models, which supports deeper understanding of multiplication and place value. It also allows for real-time interaction and engagement, which helps sustain attention and motivation throughout the lesson. From a pedagogical standpoint,
This lesson aligns strongly with constructivist learning principles. Students are actively constructing their understanding through experience rather than passively receiving information. It also supports problem-based learning because students are working through challenges, testing strategies, and adjusting their thinking as they go. Another important affordance is collaboration, which allows students to learn from one another and explain their reasoning, something that's especially important in math instruction. One thing I really appreciate about this lesson is that it naturally supports differentiation. Because the game environment is flexible, teachers can scaffold support or extend learning depending on their students' needs. Some students may focus on building basic models, while others can move into more complex multiplication challenges. This makes it more accessible to a range of learners, including those who may struggle with traditional methods. Of course, there are some challenges to consider. One challenge is making sure that the focus stays on the math and not just the gameplay. Without clear guidance, students could become more focused on exploring the game rather than engaging with the learning objectives. Another challenge is ensuring that all students are comfortable with the technology, as that can really impact how effectively they engage with the lesson. This is where the teacher's role becomes very important in structuring the experience and really providing clear expectations. Overall, I think this lesson has strong potential for classroom use, especially when it's intentionally integrated with instruction. One way I would use this in my classroom is as a supplement to a multiplication unit where students first learn the concept and then use Minecraft to apply and deepen their understanding. I would also incorporate reflection activities where students explain how their builds represent multiplication and how their strategies work. This helps connect the gameplay back to the math concepts, which is where the real learning actually happens. I also think this lesson could be used to support collaborative problem solving, where students work in pairs or small groups to complete challenges and explain their thinking. This not only strengthens their math skills, but it also builds communication and teamwork, which are essential skills both in and out of the classroom. Overall, Minecraft Education provides a really powerful platform for making math more interactive, meaningful, and engaging. When used intentionally, it has the potential to move students beyond memorization and into deeper conceptual understanding, which is something I'm always striving for in my own teaching practice. Thank you for listening to my Minecraft video review number 2. Hello everyone, my name is Kwajane Sanders and this is my Minecraft video review number 3. So for this video review, I'll be exploring the Minecraft education lesson on long division and evaluating its potential for teaching and learning in the classroom. So first, this lesson is designed to really help students understand long division by combining both conceptual and procedural learning. Students are not just solving problems on paper, they're also building models within Minecraft to represent division concepts. What stands out to me with this lesson is that students are essentially visualizing the division process, which is something I know can be really difficult for them when it's taught in a more traditional way. This lesson specifically has students build long division models and then apply that understanding to solving problems using the standard algorithm. From my own teaching experience, long division is one of those topics where students either memorize steps or completely shut down. So I really appreciate how this lesson tries to bridge that gap between understanding and procedure. In terms of game features, Minecraft Education provides an immersive and interactive environment where students can move through a structured world, interact with NPCs, and complete tasks step by step. Students are actively building, exploring, and problem solving rather than just completing a worksheet. There's also an element of immediate feedback where students can see whether their model or solution makes sense based on how they constructed it. Another important feature is the ability to collaborate, whether that's working in pairs or discussing strategies, which naturally supports communication and deeper thinking. Now, when I evaluate the pedagogical potential of this lesson, I'm specifically looking at both technological affordances and pedagogical affordances. From a technological affordance perspective, Minecraft allows students to physically manipulate and build representations of mathematical concepts. This is something that would be very difficult to replicate with traditional tools. Students can visualize how numbers are grouped and divided, which supports spatial reasoning and conceptual understanding. The interactive nature of the game also increases engagement and motivation, which is something I've definitely noticed in my own classroom when students are given more hands-on or digital experiences. Research also supports that Minecraft-based learning environments promote problem-solving, collaboration, and deeper engagement with content. From a pedagogical affordance perspective, this lesson aligns strongly with constructivist learning. Students are actively building their understanding rather than passively receiving information. It also supports problem-based learning because students are working through challenges, testing strategies, and adjusting their thinking as they go. Another key affordance is that it supports multiple entry points for learners. Some students may focus more on the visual model, while others may connect more with the algorithm, which helps support differentiation. One thing I also want to point out is how this lesson supports the connection between conceptual understanding and procedural fluency. Students are not just learning the steps of long division, they're understanding why those steps work. That's something I personally struggle to teach sometimes because it's easy to fall into just showing the steps and moving on. Of course, there are also some challenges to consider. One challenge is making sure that students stay focused on the math rather than just the gameplay. Without clear expectations and guidance, it could easily turn into exploration without learning. Another challenge is making sure students are comfortable with the technology, because if they're struggling to navigate the game, that could take away from the learning experience. This is where the teacher plays a really important role in structuring the lesson and supporting students throughout. In terms of classroom application, I would use this lesson as a supplement to a long division unit rather than as a standalone lesson. I would first introduce the concept and steps of long division and then use Minecraft as a way for students to deepen their understanding and make connections. I will also include a reflection component where students explain how their model represents the division process and how it connects to the algorithm. That reflection piece is really important because it helps students move from just doing the activity to actually understanding it. I could also see this being used in small groups or centers where students rotate through the Minecraft activity while I work with another group. This will make it more manageable and allow for more targeted support. Overall, I think this lesson shows how game-based learning can make a complex concept like long division more engaging, interactive, and meaningful for students. When used intentionally, it has the potential to shift students from memorizing steps to actually understanding the math behind what they're doing, which is something I'm always trying to improve in my own teaching practice. Thank you for listening.